Hi everyone, today we are going to continue learning about proportional relationships, but we're going to be looking at the values of x and y. This is going to help us next year when we start to graph x and y to see if they form slope or a straight line. So in today's lesson, we are going to start with a ratio table, and we're going to look at the values of x and y and see if they form a proportional relationship. If we remember back a couple lessons, proportional relationships just means that they have two values that are equivalent. So in today's, we're going to be looking at multiple values, not just two. So we're going to have a table that looks like x and looks like y. And in our table, we are going to have some values. So when x is 2, y is 5. When x is 4, y is 10. And last but not least, when x is 8, y is 20. And we want to know, do these form a proportional relationship all the way through? So are x and y proportional? Do they have the same values? So 2 over 5 is already simplified as 2 over 5. I cannot make this any smaller. If I were to do 2 divided by 5, I would still get 2 over 5. So that's this value. Now let's look at 4 over 10. 4 divided by 10, I can divide by 2 over 2, which gives me 2/5. So this value right here is 2/5. Let's use a different color. So the value of this one is 2/5. The value of this one is 2/5. And let's check 8 over 20. So now we're going to look at 8 over 20. And does this one form 2/5? 8 divided by 20. I can cut this by 4. So we're going to divide by 4 over 4. 8 divided by 4 is 2. 10 divided by 4 is 5. So the value is 2/5. So since each of these is 2/5, the answer is yes, they are proportional. And the value is 2/5. So the whole table has a value of 2/5. Okay, let's look at our next example. Example B. Example B has x and y. So again, we're comparing x to y. Again, next year we will start to graph these to form a line, or use it in slope, I should say. So next year we'll be using x and y with slope. And we're looking at 6 to 2, 9 to 3, and the last ratio is 15 to 5. So our first job is, let's find the value of 6 to 2. So if I take this ratio right here and I do 6 over 2, I can reduce this down by dividing by 2 over 2, and that's going to give me a value of 3 over 1. So that's the value of this one, 3 over 1. Okay, let's do 9 over 3. I have 9 divided by 3. I can divide by 3 over 3, and that gives me a value of 3 over 1. So far, so good. So far, so good. And then the last one, let's look at this last value. We have 15 over 5. So we're going to do... We're going to divide by 5 over 5. That gives us 3 over 1. So the value here is 3 over 1 and 3 over 1. So therefore, Therefore, our value does show a proportional relationship because each of these is 3 over 1. So this one is yes. The value is 3 over 1. Okay, let's do another example, and this time let's try one that does not show a proportional relationship. And this example is also going to be showing some fractions in there. Some fractions. So let me get that one out for you. Okay. So we have x and we have y. The first one is 1/2 over 2/5. So we're going to have to do some keep, change, flip here in this problem. And then we have 1/3 and 3/5. And the last comparison is 1/4 to 4/5. All right, let's check the value of the ratios here and see if x and y form a proportion. So we're going to do the first one here, which is 1/2 divided by 2/5. So we're going to do 1/2 divided by 2/5. Remember, we're going to use keep, change, and flip when we're dividing fractions. So we're going to keep it, we're going to change it, and we're going to flip. Now we're ready to multiply, which is 5 over 4. So the value of this first one is 5 over 4. Let's check it with the second one. Okay, number 2, we're going to do 1/3 divided by 3/5. Again, we're finding the value of the ratio so that we can compare them. We're going to keep it, we're going to change it, and we're going to flip it. We get 5 over 9. Ooh, these values are not the same. These values are not the same. Let's check the last one just to double check and make sure. So the last one, we have 1/4 divided by 4/5. We're going to keep, change, flip again. Keep it, change it, and flip it. 1 times 5 is 5. 4 times 4 is 16. Okay, so 5/4 is not the same as 5/9, and 5/9 is not the same as 5/16. None of these go together. None of these match. So this one is no, not a proportion. And that's because the values are different. All the values are different. Okay, I'm going to go ahead and turn the page now, and it's time for you to do a try it. But before I turn the page, I want you to make sure you finish writing this one down. So be sure to hit pause if you need to. All right, and for the try it's. Okay, try it number 1. Try it number 1. We have x over y. Are these proportional? We have 3/8. We have 6/16. And last 9/24. Do these form a proportional relationship? And then try it number 2. Scooch that up. Try it number 2. We have x and y. Do these form a proportional relationship? Oh my gosh, I'm sorry, my boxes are so small. Okay, we have 2 over 4. 4 over 2. 8 over 1/2. And 10 over 1/4. Okay, so go ahead and hit pause right now so you don't hear me solving, and then when you're ready, come on back and hit play. All right, so 3/8 is already reduced. There's nothing that we can reduce that down by, so 3/8 is for that one. And we're going to check number 2. We get 6 divided by 16. We can reduce this one by what? 2. And that gives us 3/8. Ooh, so far the values match. Okay, last one. 9/24. We can divide by 3/3. That gives us 3, and that gives us 8. So 3/8. We have 3/8, 3/8, and 3/8. So yes, this one is proportional. And the value is 3/8. Okay, let's do our last problem. In the last one, we're going to start with 2/4. We can reduce this by 2/2, and that's going to give me 1/2, 1/2. So the value of that one is 1/2. Okay, let's check this one, 4/2. So I'm going to divide by 2 again, and I get 2/1. Ooh, those are not the same. Let's keep going and see if any of the other ones are proportional. 8 divided by 1/2. We're going to keep change flip. So we're going to keep 8/1. We're going to times and we're going to multiply. And this gives us 16. Okay, that's definitely not proportional. And let's try the last one. We get 10/1 divided by 1/4. We're going to keep change flip. And that gives us 10/1 times 4/1. And that gives us 40. Oh my goodness, definitely not proportional. So this one is no. They all have the same, or all have different values. None of them are proportionate, and so this x and y are not proportional to one another. This would not form a straight line. Okay, go ahead and answer your essential question. How do we determine if x and y form a proportional relationship? And then go ahead and put your level of understanding out to this side. Where are you at with your learning? When you are finished, you may come on back to the Google Meet and ask for help, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.